Welcome to the podcast, The Hydrogen Leader. In this episode, I speak with Maike Schmidt from ZSW, which is a very important institute in Germany, about the future energy system. She is leading the relevant department, and we have an interesting dialogue about the future energy system, the role of hydrogen, the hydrogen backbone, and the role of hydrogen hubs. And last but not least, this is a spoiler, we have also identified an industry which has a huge hydrogen demand, which can be an anchor for the entire European hydrogen industry to grow. So I hope you will enjoy the discussion with Maike. Stay tuned, it will be great. Welcome, Maike Schmidt, to the podcast, The Hydrogen Leader. I'm delighted to have you here.
Thank you for having me. I'm happy to talk to you today.
Great. So as you know, this format is about sharing insights and telling interesting stories around and in the hydrogen economy. And you are a very important person at the ZSW because you are leading as a head the strategic system analysis, which is dealing with the future energy system. Yeah, so I think it brings a unique perspective to this industry, and I would like to kick off our little discussion with the very basic question: who is Maike Schmidt? Please be so kind to introduce yourself.
Thank you very much. So I'm a really passionate person and enthusiastic, but most of it, I'm curious. I want to figure out how the things work together, what determines what, and how a system works together. And this is why I am in the Department of Systems Analysis, and this is why I'm looking from a strategic perspective onto the energy system as a whole, and looking what determines what, how can everything work together in a future world where we are no longer dependent on fossil fuels, where we work with renewable energy and we work climate neutral. And from the background, I am an economic engineer, and this is because I was talented when I was young, but there was not one talent striking out. So I had to, and I was interested in everything in economics, in engineering, in natural sciences. And so I decided to do a study combining both the economic side and the engineering side. And it was with a focus on environmental and energy management. And so the path was straight, clear. I wanted to go into this. And in the background, since I was a little child, I wanted to save the world. And first of all, I thought I saved the world as a doctor. Right. And I save the humans, I help humans, and I treat them well and help them to stay healthy. But then I had a friend studying medicine, and I figured out, okay, this is not for me. This is too tough, and I don't want to be that tough in future. Mm-hmm. I want to keep my empathies, and I want to keep the feeling with others and not being so tough in the decisions. And so I had to find something different. And then I was looking for, like I said, a study fulfilling my multi-talents. And so I came to this environmental and energy management. And so I knew, okay, this is the way to save the world. And now I'm here.
So let's save the world together. So thank you for sharing this, Maike. And for those who do not know the ZSW already, so it's an important organization based in Ulm and Stuttgart in the southern part of Germany. But what is the focus of this institute?
So we are a research institute, an independent research institute, and we are working on technology transfer. So we are not a basic research institution like a university where we do the really basic things, but we always have in mind that what we develop should go into the market, that we want to have a product in the end helping the energy transition. And this is why we have this role in between universities and industry, where we try to develop technologies to a point where the industry can step in and say, okay, it's not that risky anymore. I know the basic design, we can take over and develop into our product. This is what we try to do at ZSW. And we, from the systems analysis, try to help to make this happen. So we try to discuss with politicians what are necessary measures to help the to close the gap of economics, which may be there for new technologies, or to make sure that with the regulation it's possible to bring the new technologies to the market. And I started in the area of renewable energy, renewable power production. So my first project at ZSW was the Renewable Energy Sources Act, and I was looking at the development of the technologies, if they develop in the way that was expected in the act, which gives the incentives for the different power productions, like photovoltaics, wind energy, biomass, and so on. And we were looking at the technology development, if it develops the way expected, and if it develops faster, then we would have to lower down the incentive so that it's getting into the market smooth. The development is not broken, but is still progressing. So it was the progress report of the Renewable Energy Sources Act, which was my first project.
To find out basically how much support this new technology needs to be activated.
Yes, because in the year 2000, we started with the Renewable Energy Sources Act, guessing what is the gap between the market price and the renewable energy sources. And so the progress report looked at the development in the market and the price development, and if it's still the right incentive, or if we have to make it higher or lower to get into a straight market.
So I need to tell you a story, because when I started as a founder of Highfinder, I was listening to one of your speeches, and you were introduced by the time as the hydrogen brain, or the energy system brain of the ZSW. So when did you focus on hydrogen, and how did it actually start with the hydrogen?
So I started at ZSW in the year 2006.
Yes.
And then we were working on the first step of the energy transition. So this was first electrification and making renewable power work. We always had in mind hydrogen, because the ZSW always worked on hydrogen, like in fuel cells and also for the electrolysis for the production of hydrogen. But when I started, it was not the time to step into the market. We were developing technologies, but we were not yet at the point where we really needed hydrogen for the energy transition. Since 2019, where we had the clear goal of climate neutrality, this completely changed. Because without the goal of climate neutrality, it is not clear that we need hydrogen. Before 2019, we always looked at lowering the greenhouse gas emissions by 80% to 2050. And if you do this, then you don't need hydrogen, because the areas where you need hydrogen could, with a scenario of minus 80% of greenhouse gas reduction, could still in the fossil world. So since 2019, we had a clear focus on how to bring hydrogen into the system for getting climate neutrality for Germany in 2045, for Europe 2050, for Baden-Württemberg 2040. So it's not a long time which is left to get into this transition. And this is why since 2019, we also focus on hydrogen.
I think this is the perfect handover. So what I understand is, in that year, you realized now it's the time to work on hydrogen, because without hydrogen, we will not decarbonize Germany and also the southern part of Germany in this time frame that the politics were setting
Yes.
you, right? That was more or less the moment for you to get into hydrogen.
Yes, it was not even the time frame. It was just the fact that we want to get climate neutral.
Okay, so let's follow up on this, because I think this is a very current topic, because when you listen to the news, you hear about drill baby drill, and we had this also Fridays for Futures you don't hear anymore. Back in the days, now people talk only about the economy and somehow forget this target to become climate neutral, or it is not longer that firm. So is there a sense of urgency? What is going on in the world?
I think there is absolutely no sense of urgency, and this is really dramatic.
In the perception, you mean?
Yes.
In the public perception,
Yes,
nobody cares.
and especially in the politics.
Right.
Because I think it's absolutely correct. We have to care about the economy because it's our wealth, it's our welfare, all depending on this. But we have to make sure that recovering the economy works hand in hand with climate neutrality. If we don't do this now and look at drill baby drill or getting more fossils in because this is maybe cheaper, then we do a very great mistake. Because then we have to do it later, and it's more expensive, and it has to be done much faster then. So I don't know how, within a time frame of 15 years till 2040, when should this transition start then? We have to do it now. We don't have any time. And it's not because there are the dates of 2040, 2045, 2050. It's because climate change is really taking place. Yesterday, we had an announcement of the European Weather Commission saying that Europe is heating the fastest in the world. It's double, double.
It's accelerating.
Yeah, it's accelerating, and it's. We will not be able to deal with this if we don't start now. Right. And we in Baden-Württemberg, we already have a temperature 2.7 degrees higher than 1881. Mm-hmm. And if we are not able to manage to get the CO2 emissions down, then we will have a temperature rise till 2040 of about 3.5 degrees in Baden-Württemberg. Right. And we don't know how to handle this. So the 1.5 degree or 2 degree line that was set in the Paris Agreement is not because it's just a number. It's because scientists say that with keeping this, we can keep the climate change. We will be still able to handle the climate change. If this rises higher, we don't know which dangers we will be in.
So I totally get it. And what you're saying is basically the science is confirming that the political timelines are the right ones to go for.
Yes.
It's not about achieving the political goals. It's about the nature that is changing.
Yes.
One could say, okay, we had this climate goal of 1.5 degree. Now people are talking and measuring 3 point. But I think this is also not the case, right? Because I think the consequences,
yes,
those are the things that matter.
Yes.
Whether it's 1.5, 2% or whatever. And tell us, why is this, if you are now expecting 3.5% for Baden-Württemberg, what could happen without making the people fear the future? But the people need to understand it's not about an academic number, right?
Yes, it's like we will see or face much more extreme weather.
Right.
So if you think about when it has rained last time, do you know? Do you remember?
And not only, a big rain. Well,
not only a few droplets.
Yeah, so I had many hails in my area, and they are quite severe, and they are also damaging houses and cars and things like that. And that happened basically 3 times in the last 5 years.
And if you look outside right now, we have a very warm April.
Yeah.
We really liked it because we feel like we're coming from a long and cold winter.
Yeah.
This was just a normal winter, like we have faced it all the time in the past. The last 10 winters were much too warm. So it's not a long, cold winter we're coming from. We're coming from a normal winter. But everyone likes it. It's warm outside. But if you look underneath the grass, the earth is dry, is really dry.
Right.
I don't know how we can manage this. And the problem is with the temperature rising, the evaporation rate is rising, but not the rainfall. We see from the data in Baden-Württemberg, in Germany and Europe, that the rainfall is still the same level. So this looks good. But as the temperature of the atmosphere is rising, the evaporation rate is rising. So there's much more water evaporated, and it's not raining back. Yeah. So the water is transferred to the ocean or somewhere else where it rains, but not in Europe. And this is why we're trying out. And when I was a child, nobody cared about water. Everyone said, no, Europe is safe for water. We don't have any problems, especially in Germany. But now I was always in water saving. So my parents were activists with Greenpeace. And so the magazines were lying around with pictures from Africa and drawn out soil and so on. And so I always kept in mind, okay, you have to shut down the water when you're breathing your teeth. So I was always in water saving. But nowadays, I
being
see,
a good role model.
Yeah, but nowadays I see that this is something that I really have to do for the future. It's nothing that is nice to have. So we will face the problem of water scarcity even in Germany. And this is something we have not really realized already. So this will change our agriculture. This will change our tourism. This will change a lot because there's not enough water there anymore. Yeah. And this is just one of the risks of climate change. And what you've talked about, like hail, like heavy rainstorms, like thunderstorms, like too much water in a very short time. Yeah. This is something that will happen very often in future. And in the past, we've seen some of these trouble already. Ahrtal in Germany, or last year it was in the eastern states in Europe, and there was a lot of damage. And in former times, there was always a politician coming with a big purse, saying, no problem, it was not your fault, we give you the money so you can rebuild everything. These situations will be so often in future that there will nobody with a big purse. We will lose a lot of our
ability to mitigate economically.
Yes.
Right. And I have had this discussion that even the big insurance group says this is no longer able to be insured because the risks are getting higher and higher.
And they are talking about a 3 to 4 degree warmer world, which is not insurable.
Exactly.
And when we are talking about 3.5 degree in Baden-Württemberg or in Europe, this is not insurable then.
Oh.
And this is something you have to keep in mind. And this is why we have to be much faster and much more strict in doing the transition, especially for hydrogen.
And I'm glad that we have you here because we now understand that there is, let's say, not this awareness in the society or with important stakeholders, right? It has been some years now, it's drifting a little bit down. But your job is to help our country to come to a good energy system, right?
Yes.
And I learned that hydrogen plays a big role. So can you explain again why we need hydrogen? We build a lot of wind and solar. Why now hydrogen in the overall setup?
When we started with the energy transition, there was a lot of thinking about electrification and about the power system. So we wanted to make the power system green first. This was really strategic and sensible because we had the coal burning, which is the most or the biggest emission source for the whole energy sector. So to get rid of this first was the best idea.
Right.
But we still have the fossil fuel in the system, a lot of fossil fuel in the system. Not so much in the electricity production, but in all the other sectors like heating, space heating, process heating for the industry. And the transportation sector. So there's a lot of mineral oil and natural gas or methane in the system. And we need solutions for this. So a lot of this can be offset by electrification. Look at the electric mobility, battery-driven vehicles. This is a good idea to do this,
Yes.
But it's not for all applications. There will still be some applications not being able to electrify. And therefore, we need then other molecules without carbon. Or with neutral or carbon neutral. And so this is where hydrogen gets in.
Yeah, I also learned this only recently, that oftentimes you hear in the news that Germany has already in the electricity something like 70 or 80% completely from solar or wind, right? But what people don't realize is that the entire energy demand of Germany is only 20% electricity, right? And
Yes.
most of the energy demand is, as you said, molecules.
Yes.
Yeah, and there is a limit to decarbonize this big chunk of 80% with electricity, right?
Yes.
That's the problem that
Yes,
we are
that's
facing.
the problem.
And that is the difference that you said from 2019. If we tackle this big box, then hydrogen needs to come into play, right?
Yes.
Okay, so you talked already about applications, and we have a lot of chicken and egg discussion. I don't want to go that rabbit hole here, but what is for you the most obvious case where everybody understands that we need hydrogen in a concrete way?
So if you look at the electricity system,
Yeah.
then you see we will build a lot more wind energy turbines onshore and offshore. We will build a lot more photovoltaics, and we may build a little more bioenergy and hydropower. But there's not so much potential to really widen this. So it's the fluctuating energy, photovoltaics and wind energy, which will determine our system in future. And everybody knows the situation that there's not enough solar and there's not enough wind, called Dunkelflaute in German.
Yeah.
And everybody is afraid of this situation. So we need a solution for this to make our energy system, our power system, as stable as we have it today and as secure as we have it today. There we need hydrogen to step in, just to fill the gaps where photovoltaics and wind energy are not enough.
Is there also no other solution for that? Is hydrogen green the only option? Because you could argue we could take something else.
We already take something else. We have biogas in the system, but there's not enough potential to use more bioenergy in the system to balance it out. So from my point of view, it's only hydrogen possible.
Okay.
And the other thing is we will have situations where we have too much wind and too much solar, which our grid cannot pick up.
Yeah.
So for these situations, if we have electrolyzers situated in a right location, then we can use the electricity, which we could not use otherwise, for producing hydrogen, just to store it for the winter time when we then need more than only PV and wind. So this is like a storage in the overall system that we can, with the production of hydrogen, use more of the electricity produced than we could otherwise, and so use it to fill the gaps when we have
Like
not
an
enough.
energy buffer, which
Yes.
we are like a like balancing the
Yes.
system, a load balancer, if
Yes.
you will.
And this is for the longer terms. For
Okay.
the shorter terms, you can also use batteries. And
Right.
we have to do this. It's not one solution fits all. It's that we need all the technologies available to make a stable system for the future. So this, for the electricity part, I think this is obvious that we need hydrogen in the long run to make our system as stable as we know it with using fossil energies.
Okay.
But on the other hand, we have the consumer areas like the industry. And also there we have processes which will not be decarbonized without green hydrogen. And this is the steel production. If we still want steel production in Europe in the future, we have to change the way of producing from coal-based to hydrogen-based. And also other production options are depending on hydrogen in future. All those who need to have a burning flame will not be able to electrify. They need another gas. And in the best way, one without carbon.
Yeah.
So this is then those parts of industry who also need hydrogen because they need something to burn in the process, and they need something to make the heat, and so they need something without carbon, and then this is hydrogen.
Yeah, and what I realized now working in the hydrogen and learned it from Stephen, that you can even transport much more energy via a small hydrogen pipeline compared to a big electricity cable, right? So there is,
Yes,
it's quite,
thinking these systems together, the electricity, the power grid, the hydrogen as an energy carrier, but also for the transportation of energy, then you get a better stabilized and balanced system.
and
in
you
future.
have mapped that out in the ZSW, so there is a simulation available where you have mapped that out system-wise?
Not in every detail,
Okay.
and I even don't know if anyone has done that yet. There is energy system modeling, and they try to integrate hydrogen and also transporting hydrogen, but I'm not sure if there is already one having all integrated and doing optimization for the overall system. But they are always looking at Europe. Not only Germany, because we have balancing activities between the countries. Weather-like, if in one country there's no wind, another might have wind. Spain maybe have no wind. Poland in the same weather condition may have a lot of wind. So there can be balancing activities.
Even between countries.
Yeah, if everything is connected.
Yeah,
And this is where Europe is working on
Yeah.
to have a better connectors between the countries for the electricity side. And we also have to look at this with the hydrogen backbone to make sure
Exactly.
that the transition also works with hydrogen.
I think this is also worth talking about, because this hydrogen backbone is a European backbone. It's broken down in every country and even every region. So tell us a little bit more. Why do we need this hydrogen backbone? In Germany, it's about 20 billion. And what I have learned from Professor Hölzle, who is your managing director, is fairly cheap compared to the electricity grid, despite it's a big number. So what is the idea of this hydrogen backbone?
It's exactly what we have today with the natural gas grid. So we have connection and we have the transportation of large amount of energy.
Yeah.
And we will need this for hydrogen too. But the additional fact is that we then can connect regions in Europe where it's cheap to produce hydrogen because they have perfect conditions with wind and photovoltaics as a production site, to countries which have not so good conditions and which have a lot of demand because of their industry, like Germany.
Yeah.
So this is another reason why we need this connection. And the grid all over Europe allows to get import hydrogen from other parts of the world, because the grid starts then at a port, maybe in the Netherlands or somewhere else.
Yeah.
And there a ship with hydrogen on board can enter, and the hydrogen enters the grid from there. And so it's also a large distribution network.
And the timeline for this hydrogen backbone aligns with these political dates that you have talked about earlier?
Yes, for Europe to become climate neutral to 2050, I think the timeline fits.
Right.
For Germany, with 2055, should fit also. We had in Baden-Württemberg a big discussion in the beginning because Baden-Württemberg wants to be climate neutral 2040 already. And in the first planning of the first mapping of the hydrogen backbone for Germany, Baden-Württemberg should be connected in the year 2040. So this was far too late.
Right.
So there a big discussion arose, especially from the industry. They said, no, we cannot wait until 2040. We need hydrogen much earlier because we have to do the transition. And then we came into the part, and the politicians asked us, how do we get to a planning tool? How can we manage this? And so we had discussion rounds, especially with industry, and we were trying to figure out how to learn more about hydrogen demand.
Right.
And so we, in the beginning, it was clear there will be the power plants with hydrogen demand. There was almost clear.
From an academic point of view, it was already clear.
Yes, but this was also quite clear from the energy sector. They were talking about switching from coal to natural gas in their power plants and then to hydrogen in the longer term. So it was clear where these power plants will be situated.
Right.
Or located. So this was like something like a backbone. And then, of course, the academic side or the academic use, they say, yes, it's the energy-intensive industry needing hydrogen. So this was already in the scenarios for the greenhouse gas neutral Baden-Württemberg to 2040 that was integrated. There was like a demand of, I think, 30 terawatt hours of hydrogen for the energy-intensive industry, like the refinery, like cement industry, like paper production, like steel production. There's not so much steel production in Baden-Württemberg, but a little bit. So this was the part of the big focus of the big industry needing hydrogen. But in the discussion with the industry, there came out that this might not be enough, that there might be others needing hydrogen because the situation they are in maybe not offer the option of electrification. And so we came up with the decision that we have to do a survey to ask industry how much hydrogen they need. And we did this together with the grid operator here, the Terranetz BW, and also with the Industry- and Handelskammer, representing the industry to help to transfer the idea to take part in the survey and to let us know how much hydrogen will be needed in future. And we did this survey in 2023, and surprisingly, there was a very large demand. Right. So it said not 30 terawatt hours in 2040, it says 90 terawatt hours in 2000.
3 times.
Yes. So there was demand from industries that we did not have expected. Yes. From producing food, for example, from the car manufacturers. And we always had, scientifics always would have expected they do electrification. Right. That's the cheapest way. But in the situation of the survey, there were demands that we would not have expected. So, and of course, the first question was: is the demand too high?
Yeah.
Is it reliable? Yeah. Is that just wishing?
Yeah.
And so we tried to figure this out, and we were discussing with the industry, and of course they say it's not what we would buy today. Because the situation is not a situation where we already can decide if it's electrification or if it's green hydrogen. But if I have the options today, I would buy green hydrogen.
Was there a requirement? Because when you talk about the industry, I guess the cost of hydrogen also matters a lot, right?
Yes.
So how did you factor that in? Because if it is as cheap as other energy sources, people want it. But if it is 3 times more
Yes.
pricey, then the
And
people
I
don't.
think this was the biggest problem with the demand.
Okay.
Because we said, we discussed with the industry in the forehand of the survey how we should deal with that.
Yeah.
And they could not tell us how much they would be able to pay, because it depends on on a lot of external factors. And so we asked, how much hydrogen would you buy for the case that you can get it, so it's available, and it's for a feasible cost.
Right.
So it's not, we did not say any cost, and so it was just it
So
would be a
the
reliable
cost gap
source.
would not be too big,
Yes.
more or less.
And so, of course, this can be too much.
Yeah.
And of course, if renewable power would be so much cheaper than green hydrogen, and the electricity grid would be so much better or develop much faster than expected now, then it easily could be that they do electrification and they will not wait for green hydrogen.
Right.
But so this is like a lot of uncertainty in this overall process of transformation, although it's only a very short time span. But because it's a very short time span, some more might decide to get into hydrogen if the hydrogen is there. Because they might say the electrification would be a very large investment. I would have to change a lot in my production process. With the hydrogen, if I use methane today or natural gas today, this might be not such a big deal. Maybe I only have to change my CHP.
Yeah.
And all the other process elements can stay the same. And especially if I just have invested a few years ago, I would say I do this because this is the option to keep my business running. It's not a big change, and it's not the big investment. And even for the big investment of electrification, I have no security of investment because I don't know how the electricity prices will develop. And I don't know if I get the grid connection or not. And this is the kind of uncertainty which makes it very difficult to get to real demand prognosis.
I think there are 2 elements that you rightly pointed out, the availability and the price. And with regard to the availability, I have heard that many of our gas pipelines are 80% hydrogen ready already. What does that mean, being hydrogen ready in parts?
The core grid of hydrogen, which should be built in Germany, is 60% existing gas infrastructure and 40% new erection.
Right.
So most of the pipes, and this maybe it's the 80%, I don't know the number exactly, are able to transport hydrogen. Already. There is not an exchange necessary. What is necessary is to change the pumping stations, because hydrogen has different or needs a lot higher pressure, and this is why we need different pressurizing stations. Right. And for most of the pipes, they are already done from plastics, and this is not a problem to transport hydrogen through this. If it's steel, then we have a problem, and there might be it might necessary to exchange parts of the pipeline. But most of the pipelines are already hydrogen ready, and you could transport hydrogen through it. And there's also one part of the core grid where already hydrogen is transported. This is near Leuna.
Yes.
And this is, I think, 30 kilometers where the grid already has transferred to be a hydrogen pipeline.
But that's not in Baden-Württemberg.
That's not in Baden-Württemberg, no.
But so is there an engineering certificate required that somebody testifies that this is hydrogen ready, or is it just an assessment? We know we build it and it should work, because this can also take quite a long time.
Yes, I think this is in the responsibility of the grid operator.
Okay.
I don't think that they will operate something which is not safe.
Yeah.
So it's,
They
I
will do
think,
it.
their own responsibility anyway, and I think that they are checked.
Okay.
So
Okay.
as they have to stay conformed with all safety regulations, and if they want to transport hydrogen, there are different safety regulations than to methane or natural gas.
Okay, but this connectivity that you mentioned from Europe to Germany and within Germany, I think in order to, let's say, have a significant impact on the entire energy system, we need to have all these new pipelines built,
Yes.
certified and connected. And it's not
Yes.
helpful to have, let's say, 5 kilometer working.
Yes.
The entire system
Yes.
must be connected, right?
Yes, and from my point of view, the parts which have to be newly erected, we have one here in Baden-Württemberg where the building started last year in April.
Yeah.
So this is
They are working on it?
already on the way.
Yeah.
And so I think it's planned in the right way to just do the connections which are necessary where today there is not a methane pipeline. There we built a hydrogen pipeline because we know there will be a big demand. And so this is, I think it's planned in a sensible way.
Yeah.
So to use the old pipelines where you don't need them anymore for methane, to switch them to hydrogen where possible, and then do the connections Europe-wide. So I think this is the planning process was done well, and it's also on the way.
Yeah, and I think what also many international participants don't realize, because it's not part of the news, in Germany, lots of energy is provided by local publicly owned energy providers, right? And what I realized is that they're really working on it. Yeah,
Yes.
and they are working on it because there is a law saying you have to do it. And we have this little, let's say, yo-yo politics on the bigger scale. But when you talk to the people on the ground, they have daily projects that they are progressing and working towards this goal of connectivity, right? And I think this should give also everybody who wants to sell hydrogen to Europe or to sell within that this is actually worked on, regardless whether we have a shaky politics, right?
I'd say so, yes.
Okay. And now talking a little bit about the price, because let's assume that all this system is up and running there. We know, as you rightly said, there could be hydrogen supplied via the ports, but also local production is possible. But let's assume a situation that we get there. What is your prediction for the hydrogen price? Because this is relevant also for the industrial players, right? If they want to do a project, they need to know the economics as well.
Yes, and this is something still unknown.
Okay.
So, of course, you can do calculations on the possible costs.
Okay.
And on this point, I have to criticize many studies because they only look at the potential of renewable energy production and the possible price because of the potential was just there, not recognizing that in the country I'm talking about, it may be much more expensive to erect renewable energy power production, maybe because there's no grid there already. And it's also often not taken into account that this might be politically risky countries where an investment needs much higher incentives to be done. Compared to Europe, maybe. So I think many of the costs are not real.
Okay.
So probably hydrogen is more expensive than said in many studies.
Okay.
So
even if the grid is, even if the backbone is there.
I think so, yes.
Okay.
But maybe it's possible to produce hydrogen for €3 per kilogram or below. I'm not sure about that. And one other point is that we have expected a very quick pathway to develop hydrogen and hydrogen production. We see now that this is not so fast. So
Yeah.
the cost is not going down so fast, or not as fast as projected.
Right.
So we are still working on erecting electrolyzer capacity. We are still working on industrializing the production. We are not there where we have all this done, and so we have not yet run through the cost curve for getting a cheaper hydrogen. So it's still under technology development. And of course, you look at learning rates and something, giving a projection where we will come out in the end. But I'd say we cannot say this seriously today. But what we can say is how much it will cost when we produce the hydrogen locally.
Okay.
Because then we know we will have a smaller electrolyzer we can maybe buy already today. We know the production cost of the electricity for this location, and then we can calculate how much the hydrogen will be. And of course, this is more expensive than that what we expect from the grid, but you can get it today or tomorrow. So if you have a need to get into green hydrogen very quickly, because this is your only option maybe, I don't know who might give pressure on you to do this, but this could be the case that you say, I need this, and I need this 2028. And in Baden-Württemberg, 2028, you won't get any hydrogen via backbone. First pipeline being in Baden-Württemberg will be 2032 if everything is on plan.
Right.
So if you need it earlier, and I think from the survey of the demand, there were many industries wanting hydrogen earlier, till 2030 or the latest 2035. We don't know if the grid will be there until then. So let's start with local hydrogen hubs. Producing local hydrogen for a higher cost, but these hubs can also be integrated in the energy system. They can give heat for space heating. They can give oxygen for some need in the industrial need in the area. And so there will be an integration, and maybe this then lowers the hydrogen cost compared to only selling hydrogen. So I don't know if this will be feasible for the long term, but as far as we have calculated it, the locally produced hydrogen will be feasible even in the long term, and even if there is the hydrogen grid there, if you use the location sensibly, or choose the location sensibly today.
Yeah, I think there are good examples already. Even in Germany, in Bavaria, we have this company H2B, which Dr. Brunner is leading, and they produce in a local setup by clever using the excess energy for hydrogen production. And they come out with, let's say, parity of diesel, and they refill trucks with green hydrogen. So I think what you're saying,
this is the business cases that we have to find, and so we can start. And I think this is already happening. So it's not only the news or the bad news that you hear that the steel production stepped out of the hydrogen way or whatever. It's also, or against it, there's the local success stories. And these business cases we have to focus on, and we have to try to develop them further on and to multiply them.
So if I understand you, you mentioned this topic of hydrogen hub or local projects. I think the beauty about it, it's creating also jobs within Germany, not just buying hydrogen from outside. So what do you characterize as a hydrogen hub, and what communities or people should focus on if they want to create a successful hydrogen hub?
So from my point of view, you need three parts. First is the hydrogen production. Or maybe this is second. First is the hydrogen demand. You need someone who needs hydrogen. Without, you don't need any hydrogen hub. But if you have the demand, and you know there will not be in a foreseeable future a connection to the grid, then you have a good location. And then you have to look for a production of hydrogen. And there you might look if there is already surplus energy in your region. If there's too much photovoltaics there, if there is already a situation where the wind energy might be curtailed. If this is the case, then you have a super perfect location. If this is not the case, you can also check if there's more potential for photovoltaics and wind energy, and erecting new power production for the hydrogen hub, or integrating ongoing projects to tell them this is fine. We also buy electricity from you for our hydrogen production, and also maybe in discussion with the grid operator where the best location is to help the electricity grid with this electrolyzer or with the location of the electrolyzer. Then you have a perfect match. And of course, you need in between as a third component, the transport from the production side to the demand side. This is not always directly located in one side. Then you may have old gas grids you can use, or you may need trailer transportation. And so this is something you have to think about to make sure that the hydrogen hub can work easily. But you have the chance to use infrastructure which is already there. So there will be no stranded assets in old infrastructure for fossil. So this is something where you can get more actors activated when they see they are not the losers of the situation, but they can also win, and then they can take part.
So these are not demonstration projects. These are projects to last, with the purpose of creating something viable, right?
Yes.
And do we have also in Baden-Württemberg some good hubs, or where people can go? They can always talk to you and learn, but do you know some good examples where you say, I think this is a great approach that they are pursuing in a certain region?
I think there are two projects. They are called model regions.
Yes.
One in Stuttgart, the project H2 Genesis, and one in the region of Ulm, the project H2 Wandel, where you can get in contact and you can see showcases. Most of the time are not one project, but being some smaller projects together in one to form this model region. But there you can already see things working. And Baden-Württemberg is also working on developing hydrogen hubs. Last year there were, I think, 10 projects chosen where now the hubs should be erected. We're starting with relatively small production of hydrogen from 1 megawatt to 10 megawatt, but 10 is relatively big already for the demand that we have in place. So, but this was one factor for getting the money from the state, that they have to show there's not only a production, but there's a demand, and how they will put it together to make this work and to make it work sustainably, not only for the phase where you get the money from the state, but also later on. So this is only getting seed money in, and then the process will be economically feasible and will not change afterwards.
So this is good. I think in the last part of our great discussion, dear Maike, I would like to pick an industry. And you mentioned it before. I think the cement industry is quite interesting, because I think it is an industry which creates a lot of CO2 and is currently also facing a lot of regulatory pressure. Can you explain the situation of the cement industry? Probably in Germany for the first, but what is the situation of this industry?
I think we have to look at Europe, because it's the same for all cement plants in Europe. They are under the European emission trading system.
Okay.
And the emission trading system works. Most of the people listening might know how it works. So I
don't know. Please explain.
So if you are a cement plant owner, then you emit a certain amount of CO2.
Yes.
And you have to buy allowances to emit this amount of CO2 in the emission trading system. And then looking back, they will ask you how much have you emitted? Have you enough credits to? And if you don't have enough credits, then you have to buy something more or some more, yes, so that you have balanced the emission you had or your plant had with the certificates that you bought.
And this is already in place now?
This is already in place now since 2005.
Okay.
Today, many of the certificates don't have to be bought. They are given to the industry for free.
Wow.
And so the next steps will be from the year 2030 on that they have to buy a growing part of the emission certificates.
So those certificates become economically relevant as a cost factor.
Yes. And after the year 2038 is the last year when new certificates will be given.
Is that a political intention or is this a hard-coded law?
Today it's a hard-coded law.
Okay, so there is a real sense of urgency to act.
So there's an end of new certificates in 2038.
Punkt.
Yes. And from this day on, if they still want to produce, they in the first 2 years may be able to buy some certificates from the market. If other industries have been more successful or faster in greenhouse gas reductions, it might be able to buy some certificates. But science says maybe it's not longer than 2040. Yeah. So after 2040, then you have to do something different. And for the cement industry, there is not the option to electrify or to get rid of the CO2 production via any change in the energy, because 2/3 of the CO2 production from the cement industry come from the cement process, from the burning process.
From the product, actually.
Yes. So this is why they need something different. They need carbon capture.
Yeah.
Without carbon capture, they are not able to get greenhouse gas neutral, and they will not be able to produce in the EU after 2038.
Unless they buy tickets,
yes.
But then the economic model does not work.
Yes,
anymore.
And after 2040, maybe they will be no longer be able to buy certificates because there are no in the market and no new are coming into the market.
So that's a hard stop date.
Yes.
Okay.
And maybe, of course, you don't know how politics really act. So today it's a law. So it can be that they prolong it or I don't know. But as of today, you would have to do or you would have to go into carbon capture.
Right.
And then the next step is today in the EU ETS or the emission trading system, it's only possible to use this carbon capture if the CO2 is stored. So it's not if you use it. Mm-hmm. If it's there's
you need to contribute basically.
So they have the problem is different. They could now invest in carbon capture. Mm-hmm. And there is one place in Baden-Württemberg where they have a pilot plant which should start within the next month to show that it is possible to do oxy-fuel burning in a cement plant and also to then capture all the CO2. And if this works, then they could do the investment to have the plant changed or transformed to a carbon capture plant in 2038. So this would technically be possible. But then is the question what to do with the CO2. Yeah. We don't have any CO2 infrastructure to transport CO2 to possible storage sites. We don't have any storage sites in Germany right now. There are developments of storage in Denmark, in Norway, and in the Netherlands. And right now we have the regulation in the place that we would be allowed to transport the CO2 over the border to have it stored in Denmark or in the Netherlands or Norway. So from the regulatory side, this is possible. But if there's no infrastructure, they cannot do anything.
Exactly.
So they have a real high pressure to go into this carbon capture on the one side, but they have a real high demand of infrastructure for CO2. Or they need the possibility to produce something from the CO2 on site of the cement plant, and maybe chemicals or basic chemicals, synthetic basic chemicals, to give them as a basic for the chemical industry for them to decarbonize or to get rid of fossil carbons. This is only possible if the cement industry is allowed to do this. Right now, they are only allowed to do it until 2040, because after 2040, from the EU point of view, the carbon source, as a carbon point source from cement, is not renewable because it's coming from the stone. So it's not fossil because it's not from fossil fuels, but it's not renewable. Yeah. So they say it's only possible to use the CO2 from the cement plant to make renewable fuels of non-biological origin from that until the year 2040. And afterwards, it's not an RFNBO anymore. So it will not be
compliant.
Yes. And so the situation is that the cement industry does not know what to do. Of course, they have to go into carbon capture, but there is no infrastructure, not even a planning for a CO2 infrastructure. So they don't know if the CO2 can be transported away from their sites and be stored somewhere else. And they are not allowed after 2040 to do synthetic fuels or synthetic products to produce them from the CO2 that they captured. So they are kind of in a very difficult situation. If they would be allowed to do this synthetic products from the CO2 that they captured, then they need a lot of hydrogen.
Okay.
Because for the production of synthetic fuels or synthetic raw materials for the chemical industry, you need hydrogen as a partner for the CO2. So you can make carbohydrates out of the CO2 and the hydrogen.
Green hydrogen.
Yes. Mm-hmm. And so this is why the cement industry could have a real large demand of hydrogen, but only if all the regulation around this allows carbon capture and utilization in synthetic products after 2040.
Okay, so I think there is a need to act now on different levels.
Yes.
So if I understand you correct, we need some sort of regulatory guidance. We need this infrastructure and we need players who are working on these projects. Are you seeing this not happening on all three areas, or is there some movement? Because I have talked to a CEO of a cement company, and which is why I have identified this sense of urgency. And he said he's willing to start projects, but he needs regulatory certainty that if he invests, that there will be a chance to get a positive outlook.
Yes, that's true.
So the industry would be willing to act if they would get more clarity on the regulatory front.
And they are putting pressure on politics.
Okay.
This is true. And also during the last year or maybe even 2 years, we, from the scientific point of view, have worked together with the industry to make clear to politics that we need a change here. And this is really urgent. And we need this, otherwise we will not have a cement industry after 2040 in Europe. And for cement, this is kind of difficult. Of course, you can import cement, but this does not really make sense because it's a local question, and this is also a local production, which leads to local money. So we should not give this up.
Yeah.
But the problem is you can now work on all three options. One, building the infrastructure to transport the CO2 to a storage site outside of Germany. So the law right now says we can store it under the North Sea, and the Bundesländer have the option to opt in and say, okay, we can also store it here. We don't know if we have storage sites in Baden-Württemberg already. There's some knowledge, but not enough to say, okay, here we can store, here we can't. So there would be the option, the second option, to look for storage sites in Baden-Württemberg. Right. But still insecurity if we will find some and how fast they can be developed. But if we look at storage sites in Baden-Württemberg, we might not need an infrastructure to the North Sea. So this is something being like...
So as long as all options are open, nothing is moving forward because we are not making a decision.
Yeah, part of it. And then the other question, or the third question is, don't we really not need the CO2 from point sources like cement for the production of synthetic basic material? Yeah. Because from my point of view, we are not really seriously looking at this option. Of course, on the climate conferences, we are talking about of phasing out fossils. We don't realize what that really means. This means that we will not have plastics anymore. Despite we go into synthetic production of raw materials for plastic. Yeah. And if we look at the overall need for fossil or for mineral oil products, then we think that it's not a good idea to not take point sources into account. They are cheap to catch the carbon, cheaper than catching the carbon from air. Maybe we will need direct air capture in future. Or, I'm quite sure that we will need it because of other reasons. We can talk about that later if you want. But this will be more expensive than point sources. And of course, the question is if the CO2 from the synthetic product then gets into the air sometimes. And this is the fear of the EU, why they said, no, it's not only allowed till 2040, because they say it's as an renewable fuel of non-biological origin, it will be burned definitely. So then the CO2 will be back in the air, in the atmosphere. And it's only saving half. So it's because we did not use fossil fuel, we save, but the CO2 from the cement is then in the atmosphere anyway. So it's only a reduction of 50%.
So what I realized when I was dipping into this a little bit deeper is that this year 2040, what you have described looks far away, but it is actually not. When we were talking to the leaders, it's about what we do in the next 2 years, because the timelines for these projects are so long that we really now need to decide which way to go. Yeah. And if we don't do this in the next 2 years and provide some sort of way forward for the industry, we will end up in a real struggle automatically because we cannot do all the fixing in 3 or 5 years, right?
That's it. So you need it for the planning and the erection of infrastructure. Yeah. There you need a lot of time. So, and this is not only for CO2, but we also face it for hydrogen and for the electricity grid. So this is something that really has to be done. And on the other hand, if we are looking in the option of storing CO2 here in Baden-Württemberg, then we also have to explore the sites while doing the planning process for the infrastructure, because we don't know if we find a storage site. Yeah. And if we don't find one, then we need the infrastructure anyway. So it's like we have to do the planning for the infrastructure, and maybe after the planning, before we start building, let's take a number. Maybe this is 2030, that we have done the planning and we would start into the building or the erection. Maybe we know, or we should know until 2030, if we have the possibility to store CO2 in Baden-Württemberg. If we know that then, and know how much that will cost and how it can be developed, then we have the possibility to decide if we go into the infrastructure erection or if we go into the storage or if we do both, because the storage may take the CO2 for 20 years, but afterwards we will need the infrastructure anyway. So this is something that we have to develop now. And the same, I think, is that we have to work on the regulation for using the CO2 for synthetic products, because this would be from my point of view, the best way, because then we would have, we could keep the money in the country and don't have to export. Because if you export the CO2 to Denmark, then you pay in Denmark for storing the CO2. So if you have a local storage site, then at least the money stays here. But maybe we can do something more worthy with it and produce synthetic materials so that we can stay with plastics till 2040. I think you cannot imagine that we have no plastics in 2040 anymore. Yeah. Everything we have around us is using plastics. Yeah. And I think we have to also change this. But this is not possible till 2040. Okay. So we have to look into the options, how we can do this in a synthetic way. And because synthesizing is costly, then we will see in which products it still makes sense and in which not.
So for me, without all the deep knowledge that you have, things are quite easy. Because we are building a backbone for hydrogen where people want that a lot of hydrogen is going through those backbones.
Yes.
So we have a cement industry that is in desperate need, based on your words, for hydrogen. We have regulatory that is perceived to go green, but creates lots of problems for an industry that wants to go green. So I think now is the time that we put the things together. Yes. And find the people to drive this forward, because I think the cement industry is, in a positive way, a big opportunity for the hydrogen economy again, because if there is this regulatory tipping point and the need, I sense from speaking to the CEO, he wants to invest.
Yes.
But he needs certainty. Yes. And I think that this can be a great anchor customer with a lot of demand to grow this industry and to make hydrogen cheap so that other applications then can benefit from all the hydrogen that is coming through the backbone, right? This is the vision I see.
Yes, I can share this.
Okay.
But this is only the case if the CO2 will then be transferred into products. Yeah. Only for this case, we need the hydrogen. And so it's a regulatory question. Okay. And we have to work hard on this. And on the other side, all the other options to store CO2 is also necessary to explore, to make sure that the cement industry has a fallback option if it does not function with the production of synthetic products. But with the anchor, I think this is a really
opportunity.
Yes, it's a real opportunity, and it's also a necessity. Yeah. We need these anchors. And also the power plants could be those anchors, but the regulation we are facing right now is not going into this direction. We're talking about methane plants or natural gas-fired plants without a time frame when they have to change to hydrogen. And this makes it very difficult for the hydrogen backbone because the hydrogen backbone builders and the companies using it or building it need the security that they will have these anchors in the future, and they need time frames. And if the power plants come into or will change to hydrogen in 2040 or later, 2045, no change in the system will happen in Baden-Württemberg before, because we don't have these anchors having enough demand to make the grid operators switch to hydrogen. Yeah. And this is why we actually need more clarity also in the Kraftwerk strategy or the strategy for the power plants, and also to have fixed dates when they have to switch to hydrogen. And otherwise, I think we will have large problems to really get into this hydrogen backbone. And for all the companies needing only smaller amounts of hydrogen, they will not be able to be the anchors for the grid operator. And so they will not be able to get hydrogen through the backbone. And then again, maybe the option is to have hydrogen hubs, but this is
it's not material enough.
Yes, and so it's a very difficult situation, and I understand that many are not getting into investment decisions right now because the security is not there.
Okay, so I think one of the big problems is this insecurity, but people can work on this, right? And we have a new government in Baden-Württemberg, and I sense now I basically more and more understand why they call you the brain or in the CSW to work on this, let's say, energy system of the future. It is all connected, but we need to somehow break through and start working forward, right? So for me, I have learned so much, dear Maike. Thank you for doing this. I sense that you are very passionate to make it a better world with all the knowledge that you have. I think we need people like you who can explain to the politics how everything is connected to write the right policies for a better energy future. And I hope that we will get there. Thank you very much.
Yes, I thank you. And I have to tell you, I'm a very impatient person, but with working with politics, you have to have a lot of patience.
Yeah.
But don't lose the impatience, otherwise you won't be able to bring things forward. And I really hope that we make it to bring hydrogen forward and to make this place a better world.
Thank you very much. So a small message to our audience. So for those who stayed so far, please consider subscribing to the channel. It helps us a lot to bring guests like Maike Schmidt to this format so that we can all benefit. Thank you for listening.